Hello, I am Dan Fuchs, and today I'm going to be completing my literature review presentation on Snowflake Essentials by Bill, as well as other authors and writers. I personally felt that this passage, it was actually 3 or 4 chapters taken out of a text. I felt it did a great job encapsulating some of the key features and functionalities of Snowflake, as well as not only the history of Snowflake, but why it's so important and why it was so disruptive to the industry. So with this literature review, I'm looking to go into some of those concepts and kind of break down Snowflake as a system. But before doing so, I think it's important to go over some key concepts that I'm going to be discussing today. So the first is cloud storage and cloud computing. We really saw this idea popularized in the early 2000s, but it's essentially the idea of, rather than needing to store resources and data locally, we're just able to access, remote servers out in Montana or Virginia, and access that data instead. And that data is managed elsewhere rather than on premise. Examples of cloud service providers that are more familiar these days are Amazon, Google, Microsoft. They're the 3 big ones, and also, as we'll be discussing today, Snowflake. I also believe software as a service really is an important concept to understand, which is simply just software that's accessed online with a subscription-based model rather than something we buy and install on an individual machine. So, for instance, if you remember, back in the day, if I wanted Microsoft Word on my computer, I'd actually have to go to the store and I'd be able to purchase Word, PowerPoint, and Excel as a bundle for maybe $100 or $150. Nowadays, Microsoft Office is a software as a service, so it's all accessible, through the cloud. I download the application and I sign in. So there's no need to purchase those pieces of software in the store anymore. So that's what software as a service does. Snowflake is actually a database as a service, which is essentially a software as a service as well. But Snowflake is a database system, which is specifically a relational database. You'll also see that referred to as RDBMS in this presentation, which stands for Relational Database Management System. This can be thought of as the system that contains all of the data as it relates to one another. So it's going to store multiple tables, which we'll talk about later, but it's just keeping everything organized and together so it can work collectively. As well as the idea of SQL, that kind of ties into relational databases majorly. I shouldn't say kind of. SQL just stands for Structured Query Language, and it's how we communicate with the database. Just like, if we're playing Xbox or PlayStation, we're pressing buttons and moving joysticks in our controller that's acting as the input, and that's how we're telling our console where we want to move on the screen. Just how we do that, we use SQL to communicate with a database. So we're going to type in something specific, and we're going to expect this specific result or an output out of our SQL statement. So it's a programming language meant to do that. Additionally, you'll see me talk about nodes a little bit. Nodes can just be thought of as pieces of a database that contain specific information or agendas, I guess, for users of that database as well as its resources. And multiple nodes can be put together, and they form what's known as a node network. And that's what holds our data together and allows it to seamlessly communicate. And we'll talk about a couple different models of using the information in nodes as well in this presentation. And it just so happens that Snowflake benefits from both, where traditionally that's not always the case. So let's get in a little bit to the history of big data before Snowflake was in the picture. So as I mentioned, in the early 2000s, we see the growth of cloud computing, but not necessarily for the business case, right? The business use. There weren't a lot of data management capabilities at the time. So Amazon in March of 2006 introduced S3, which we just used for storing files at the time, not data management, but of course that would all eventually change. as we began to expand and there was more of a need for data management, Apache Software came out with something that they called Hadoop, which was a platform to do just this, right? To store data and manage it. But there was a huge problem with Hadoop, which was the fact that it was very costly to use due to skill-based limitations. You really had to have employees that knew what they were doing, and they were not always easy to come by. So this is really where Snowflake came into play. They noticed that there were a lot of problems with competitors, including some of Hadoop's problems, and they realized that there were challenges associated with these problems. So Hadoop was very expensive and just too complex for most organizations. So that's why the founders of Snowflake came together and built a cloud-based, on a cloud architecture, RDBMS database system from scratch. Benoit and Thierry were actually two Oracle engineers, and Marcin was the third founder. But this is where the idea of Snowflake started, and they began building that. So what advantages do we have using Snowflake? Well, over other platforms, simplicity. I've personally gotten to work with Snowflake, and I can tell you it's a very, very easy user interface. It's very easy to learn, and you can actually do a lot of things that you traditionally do only through using code or SQL. You can actually do that through a user interface, or just, you could think of a user interface as a normal website, right? You just get to click through a bunch of things and configure your setup, your database setup for your organization. In addition to this, what really sold Snowflake for a lot of people was speed and scalability. So scalability is very simple. It's really just the need for either more data or more processing power. So as you need more of that, you can increase scale. And we'll talk about how Snowflake handles scale as well, but very big selling point for them as it was virtually unlimited. So these features alone, the simplicity, the speed, and the scale, were so important to users that people flocked over to Snowflake, regardless of the opportunity cost of switching over, because no matter what it costs, they knew that they were going to gain so much long-term out of using Snowflake as a RDBMS platform. So what makes them so different? Well, let's talk about why their scaling is so great. So typically scaling is something that required a lot of maintenance and engineering effort from your organization, but Snowflake actually automated this. So in other words, they could expand their data system for larger amounts of data or larger requests when needed. They had built-in tuning, and this was just absolutely disruptive because no one else was doing this at the time. And that is building an RDBMS on the cloud, which was fully scalable. And we can also look at their hybrid model architecture, which was really important. We're going to look at two architectures here specifically, shared nothing and shared disk. So we referred to nodes earlier in the key concept slide, but nodes are essentially bits of information within the database, right? So shared disk is a structure where nodes share storage, and shared nothing is an architecture where nodes aren't sharing memory or storage with one another. A great way I like to think of this is a hotel room analogy. So you know how there are hotel rooms that only have one door, which is the door that connects to the hallway, and there are hotel rooms that actually have conjoined rooms. So within that hotel room, you can open a door within the room and it leads to the room next to it. That are very popular for family vacations. So I like to think of shared nothing and shared disk as the same way. Shared nothing are those hotel rooms with only one door that goes into the hallway, because each node can only access its own data. But with the shared disk architecture, nodes are able to access multiple nodes' data. So in that architecture, the shared disk, we're able to share data between machines and computations versus when we're not. Snowflake uses the architecture and the benefits of both. So Snowflake's cloud services can be broken into three layers. The cloud services layer, the compute layer, and the storage layer. And they all have 3 different functions. So the cloud services layer handles the services within the database, such as authentication, which is just who can access what, as well as security, and then also optimization. So just some of the performance-based metrics and performance for queries. Queries, again, just SQL statements that we're using to search through the database. And metadata. It also handles metadata, which is just data about data. And that's all the metadata means. On the lower level, we have the computer layer, which actually handles the some of the computation, and also the virtual warehouses. And it's very important to note that this is separate from the disk storage, which is on the storage layer. So this is where, when your data is stored in these big remote warehouses, this is going to be what's communicating with those warehouses. And lastly, as I mentioned, the warehouses, we have the storage layer, and this is where the data is pulled from to be processed by the compute layer. But this is where our data is being stored because it's not on our machine, so it has to be somewhere. So it's within this storage layer that to us seems like a concept that is just something that doesn't exist, but it does exist physically somewhere in these remote warehouses. So what makes Snowflake unique? There are 5 disruptive features that were described in the text, and we're going to get to go into each one of them. The first being the separation of compute from storage. The second, automated data maintenance and scaling. We also have ease of use, we have performance, and we have data sharing. So let's take a look at all of those individually and see why they make Snowflake so unique. So the first is separation of compute from storage. So what does this mean? This is what actually enables Snowflake to have a pay-as-you-go service platform. So this was unheard of at the time. No other relational database platforms, cloud platforms have done this. And essentially what this is it means that smaller organizations have access to as much computational power as they need at a lower cost. So they're only going to pay for that power when they're using it. Otherwise, they don't have to. If they need better performance, they can pay for that. But if they don't have to. This enabled for very quick problem solving with, again, resources whenever they needed them. And this made Snowflake a really powerful tool that anyone from a small to large company could take advantage of. Secondly, automated data maintenance and scaling were a great feature of Snowflake and still are today. But traditionally, just maintenance in general and scaling of a database platform was a engineering function. And that means just like Hadoop, in Hadoop's case, you needed to have very skilled engineers that knew what they were doing and could manage your database. However, with Snowflake, we introduced the concept of cloud management being a business function. So that's not something that the organizational level would have to worry about anymore. It was all handled internally through Snowflake. And it just eliminated the need for enhancements such as indexing. And all indexing is just grouping together data to more quickly access it. Very expensive, and it's just a way that Snowflake was able to differentiate itself by eliminating the need to do that because it was done internally without using resources. So it's also important to talk about how easy Snowflake is to use, right? So Snowflake did a great job of not only bringing in new users that have never used the platform before, but also being able to capture a lot of people that have traditionally worked with database management systems and getting them to use Snowflake as well. And the way they did that was the third item here, which is SQL standard syntax. As I described earlier, SQL is structured query language, and everyone knows it because it's how we communicate with databases. It's been around since 1974. It's been used by millions of people. So that was Snowflake's way of guaranteeing that old timers per se would have no problem coming to their platform versus other solutions that don't utilize SQL. And there's a saying, you can't teach an old dog new tricks, but guess what? Snowflake had a not only minimalistic and easy to use interface, but an anyone can learn user interface, so that really, regardless of what platform you came from, migrating over to Snowflake would eventually be a pleasant experience and something that paid off in the long haul. So this is what Snowflake sought to accomplish by creating a great user interface and making their product easy to use. And SQL played a huge role in that. So this is actually a quote from the text on page 8, but I thought it was really important to include it and actually analyze what people are gaining from migrating over to Snowflake. So it says, in the beginning of 2018, I took Snowflake to one of my long-standing clients. They had been running the massive Athena job. Athena, by the way, is just a database solution from Amazon. So they were running a massive Athena job that was taking a month to complete, which is a very long time. We moved a subset of that equivalent job and was taking over 24 hours over to Snowflake during a proof of concept. It finished in less than 1 hour, and we ported it over in a couple days. So more than 24 times improvement without any tuning and optimizing. Thousands of Snowflake customers repeated this type of nirvana over the past several months and years. New Snowflake customers often see massive speed improvements of 2 to 10x or more that create massive differentiation from its data processing completion. So if we look at this, it said a 24-hour job on Athena took less than 1 hour in Snowflake, which means that a month-long job, a 30-day job in Athena, would take just a little bit over a day to complete with Snowflake, which is such a great improvement. This kind of speed is why Snowflake really disrupted the industry and made a lot of people move over. And lastly, we have the idea of data sharing. So previously we wouldn't be able to do this, but with Snowflake, they made it easier than ever through roles, which we'll talk about in a little bit, to not only share data within organizations, but across multiple organizations, which was huge. They did this through no copy data sharing, which is extremely efficient. Again, we're going to go into that in a little bit. And they also had just easy practices of data replication. So this wasn't something that was hard to set up. It was very easy to manage permissions and storage when doing this. So really great features that Snowflake introduced. So let's talk a little bit about viewing past versions with Snowflake. It's easier than ever with Snowflake, and a really great improvement over traditional systems. Traditionally, if you think about what would happen if you made a mistake in a database, you'd have to restore a backup to fix that mistake. This could not only cost a lot of money, but take a lot of time. With Snowflake, they introduced a feature called time travel, which meant you could visit a previous version of the table you were dealing with before you actually messed up with your unintended action. This was huge because if you messed something up, you'd be able to go back in time. Actually, in Snowflake, you can even undrop a table if you drop a table, which just means completely erasing the table from that database system. There's also a feature called zero copy cloning, which we'll go over, but this is what made it possible in Snowflake to clone, production-sized data sets, which could be millions, tens of millions, hundreds of millions of rows of data without taking up additional storage. And again, this just was not something anybody else was doing, and it was another great feature of Snowflake. So we'll go into that in a little bit as well. So let's talk about caching and kind of how Snowflake utilized caching. So before we talk about Snowflake, caching can just really be thought of as a temporary storage area for information. So for example, when you're going to navigate to a website, they actually cache data in your browser on your machine so that next time you visit that website, it already has some of the information it needs and it can load a lot faster. A great real-life example of caching is, think about if you're running out of your front door a lot, right? If you put your shoes in the laundry room all the time, it's going to take you a lot longer to go outside, because before you run out the front door, you have to go into your laundry room, put on your shoes, and then go outside. Whereas if you just left your shoes in the, on the mat right next to the door, you could pretty much run right to the door, throw your shoes on, and get out a lot faster. So caching could be thought of in this way to provide, faster access, or in our real life example, just faster completion of an action. So this is the general concept. And well, how did Snowflake utilize it? Well, let's start by running an extensive query, and no matter how long the query takes, we're going to have some resulting data from that query. So that's great and everything works, but what if we run it again? What if we need to run it again? Well, traditionally, we'd have to run it again and use the resources to run it again, which could be very, not only timely, but costly. With Snowflake, we don't have to. The results of that query are actually cached. So if we go ahead and run that same query, we're not going to be charged anything additionally for accessing those results, and they're going to be cached for 24 hours, saving us a lot of time and money. However, there is one caveat to this, which is only the fact that none of the underlying data can be modified. So if the original table or sets of tables that we're querying against or searching against, if that data has been modified, we're not going to be able to take advantage of query caching in Snowflake. So if that is the case and the data is changed, we will be charged for that transaction. But another amazing feature that Snowflake brings to the table is time travel. This is what allows us to, rather than have to restore a backup of a database to retrieve information from a past version, we can just visit a previous version of the table on the fly. And again, this allows us to resolve issues in just minutes or hours rather than multiple days or even months in some cases. This is the first instance where we're going to take a look at syntax. All syntax is it's the verbiage, if you will, or the typing that we use to communicate with the database, to write our SQL. So to use time travel, which we're going to see on the next slide, we're going to write some statements to interact with the database, and we're going to use some of these commands. You could specify, if you want to restore a database, you could say at a specific time. You could use offset, which what offset does is it takes the current time and either adds or subtracts from it. So if you want to see the state 5 hours ago, you could do that. You could also use time travel with a specific statement, a specific query you wrote in the past, or before that statement. So if you want to see not the result of that statement, but the state before that statement. So without further ado, let's look at some code here. So again, this is some SQL in Snowflake, but I'm saying select here, which is just in SQL how we say that we're looking to retrieve something from a table. The star just means all, which means all columns from that table. And again, I will go over this in a little bit. My table being the name of the table. Here's where our time travel comes into play. We're saying at. So now, rather than a normal select statement with any other RDBMS system, Snowflake allows us to specify the exact instance, the exact time we're going to be selecting from that table. So when we pass in a date from 2015, in this example, we're selecting the data on Friday, May 1st, 2015, rather than now. Same thing with this specific timestamp. And here's an example of using offset, right? We're actually looking to select the table from 5 minutes ago. So a really quick, easy way to fetch old data without having to go through multiple steps and waste resources. Snowflake also has an amazing feature called zero-copy cloning. So what zero-copy cloning is it's where if we need to create a copy of a table, rather than have to copy all the data in that table over to a new object, a new table, and waste all those resources and especially increase the cost, we're able to do so without doing that. We're essentially creating an instant copy or instant backup with no additional cost that shares the underlying storage of that original object. And the great thing about zero-copy cloning is it works with time travel, which is really neat. So you could actually create a copy of a database, and if you want it to be a previous version of that database, you can start creating objects with that version of the table. So really unique feature and something that you can get creative with in Snowflake. So Snowflake also utilizes roles in their system. So roles are really important to control who can do what and who cannot. We have roles in Snowflake similarly to how Rowan University might have roles on the Rowan Online system. So for instance, as a student using Rowan Online, I can submit assignments, I can view modules, I can download the syllabus, but I'm not able to do some of the things that a professor would be able to do, such as enter and modify grades, create new assignments, create new modules, things like that. So it's the same in Snowflake and any other system where we need to have permissions. And in order to do that, we have 6 permissions. We have org admin, account admin, security admin, user admin, sysadmin, and public. We're going to start at the lowest level and work our way up. Public is automatically granted to every user in the system. They can own their own objects, but all the objects are public and there's no restrictions associated with them. So they can create data they need to create, but it's going to be really visible to everyone else. Sysadmin or system admin can create warehouses, which is what stores our databases in Snowflake. And they can create databases, any other objects and variables they need to, and that's about it. Going a little higher up, the user admin is for user and role management only. So we can create a new user, we can create a new role, but that's really it. So we can create a user, assign that user a specific role, and that's all the user admin is for. It's for that specific role in the system. Security admin actually inherits the privileges of user admin, so they can manage grants. Going up, we have account admin, which combines the functionalities of sysadmin and security admin. Account admin is a pretty high up role. It's a top level role and really should only be granted to a very small number of users in the system. And lastly, I don't believe this one's actually accessible by a lot of people, but it's the org admin, which is just the ability to manage all accounts at the organizational level. So you can create new accounts, view accounts, view usage information, things like that. And then also, it's very important to note that you can actually create custom roles. So if you want to create your own role called Rowan role, you could create a role that combines the functionalities of most of these. So they could actually have sysadmin, user admin, and account admin roles if they want. So everything is able to be combined through custom roles, which is another great feature of Snowflake. But let's talk a little bit about what these roles actually manage, which are the tables within Snowflake, how we're storing that data. So tables are not unique to Snowflake. You can just think of tables as mechanisms that contain data. Tables have fields and records. So for instance, this would be a field. Name would be a field. Date of birth would be a field. And they're stored in columns. Fields are also referred to as columns. And then here we have records, which are just also referred to as rows, which contain all of the data for each column. And then this whole entity is a table. You'll notice that each item here has an ID associated with it, as tables sometimes and most of the time do. And that's just an easier way to access a row in the table by ID. There's a lot of communication that we can do with tables in Snowflake. We can create, which means to create serves to create a new table, alter modifies an existing table, drop will actually remove a table completely. But what's great about Snowflake is it's very unique in that you can actually undrop a table. Drop is always known to be a very permanent operation that is not undoable. But Snowflake gives us that option, which is just great. We also have truncate and rename. Truncate is just simply to delete data inside of the table, but not actually delete the table itself, like drop would. And rename is pretty self-explanatory. It's just to assign the table a new name. So that's really how data is stored within Snowflake. And as you can imagine, we can have multiple tables that actually relate to one another. So let's say for this specific example, right, we wanted to have, this was for actually for a car dealership or a maintenance center, and we wanted to have a database of every one of our customers as well as the vehicles they drive. So how would we relate this to another table? Well, we could have a column or a field called car or car ID, and that field would contain an ID reference to another table which we could call cars. And then similarly to this table, there'd be an ID for every car, and then we'd have different traits about the car: make, model, year, color, notes about the service, things like that. So that's how we can kind of create this relational database model, by linking multiple tables together. And that's what Snowflake is used for. But of course, not on this simplistic level, but on the level of storing millions and tens of millions of rows of data that all relate to one another amongst multiple tables. Let's talk a little bit about stages as well. This is a feature that is unique to Snowflake. So there are two types of stages. There are internal stages and external stages. Stages are, for internal stages rather, they're files that are going to be stored within Snowflake. And stages are just how we load data in the Snowflake. So when we're creating these tables, we need to load the data from somewhere. That's what stages serve as. So we can actually load hard data in through Snowflake, or we could use external stages. There are three options for external stages in Snowflake. We can load them from S3, Google Cloud Platform Storage, or Microsoft Azure. So as data is continuously added into these storage areas that we refer to as buckets, the data can actually be retrieved on Snowflake's end. In order to accomplish this, we need to provide credentials, of course, because there needs to be security associated with this. So we can provide things like the access key, the secret, and encryption keys, just to make sure that we do have permissions in Snowflake to access this data. And lastly, to conclude this presentation, let's take a look at some of the syntax around creating the stages in Snowflake. Again, syntax just refers to the nomenclature or the language we're using to communicate with Snowflake in the database. So in this instance, we're first going to create our example database in Snowflake, which I'm calling movies in this case. After that, we're creating a schema, which is just referring to, a schema is just referring to the organization of the data, and how we're constructing the database, what it's supposed to look like, how our data is structured. So we're creating a schema just to differentiate our data from the database. We're creating a schema just for stages. So that's something I can do as well. So I'm doing that here. And then lastly, I am creating or replacing. All that means is replace it if it already exists, create it fresh if it doesn't. I'm creating a stage called external stages.movie data stage. So the name of the stage is actually movie data stage, and it's just telling it to create it within the external stages schema. So this is where I can go ahead and load in data manually through Snowflake, through JSON data, which is just pre-structured string data that I can load into tables. Or I can go ahead and retrieve my data, link this stage to an S3, Google Cloud Platform, or Azure bucket. So my data can continuously be loaded in through there. Now, I use the word continuously lightly because data from the stages, data from the buckets into the stages is not always going to be loaded in continuously unless we use a feature called pipes with Snowflake, which is when we configure a pipe for a stage, it actually allows that data to be free-flowing and continue to appear in Snowflake as it's added to the bucket. So we can use pipes along with stages, just as we can use zero copy cloning with time travel. We could use a lot of Snowflake's functionalities together. And again, that's what just makes it such a powerful tool and really made it a game changer when it was initially created. As with all services, Snowflake is still coming out with new features to this day. So they're a company that continues to grow and continues to meet the needs and demands of some of the businesses and organizations that use it. But yeah, thank you for watching. And again, I really feel this text was a great way to get an introduction to Snowflake, as well as look into some of the key features and functionalities that it uses to be one of the best in the industry. And it makes sense after reading this why Snowflake is continuing to grow. So yeah, again, thanks for watching.